A difficult question this, and in two parts. So question 2.5. First of all, the first section is not too difficult. Chemical analysis shows that chlorofluoroalkane B contains by mass 51.5% fluorine, 32.1% chlorine and no hydrogen. So the remaining part is carbon. So first of all, if you work out 51.5% fluorine, 32.1% chlorine, the remainder must be carbon. So by subtraction from 100%, 16.4% is carbon. You divide the atomic mass of each of them into those percentages. So 51.5 divided by 19, that's the atomic mass of an F atom, a fluorine atom. 32.1 divided by 35.5 is the atomic mass of a chlorine atom, and 16.4 divided by 12, the mass of a carbon atom, gives this ratio. And then you divide by the smallest. So the smallest is 0.9, so if you divide them all by 0.9, it gives a ratio of 3 to 1 to 1.5. Then you multiply up into the largest whole number, so if I multiply them all by 2, that equals 6 to 2 to 3. So in there there's 6 F's, 2 Cl's and 3 C's, so the molecule is C3F6Cl2. The molecular ion that we're trying to find, so a molecular ion is the whole molecule minus an electron. So what's actually happened is that electron impact ionization, so in a mass spectrometer, means that an electron gun has been fired at this and it removes an electron and forms a plus ion. So all you've got to do is take the molecular formula and add a plus onto it. The next section is more difficult. So the next section now is, it says, determine the formula of each of the 3 molecular ions of B. So I've got 220, 222 and 224. So what are my 3 combinations? Well, my 3 combinations are including 35Cl and 37Cl. So I could have a 35 and a 35. So remember, I've got 2 Cl's in here. So I've got 2 Cl's. So I could have a 35 and a 35. I could have a 35 and a 37, or I could have 2 37s. So they've either got to be both 35s, one of each, or 2 37s. If you add up the MR with 2 35s, 2 35Cls, that's going to give the lowest MR at 220. A 35 and a 37 will give a slightly higher MR at 222, and a 2 37s will give a 224. So that then gives you this here. So this here, so 2 35s, 220, 35 and the 37, 222, and a 37, 2 37s gives a 224. Okay, so those are the combinations. Now, predict and explain the ratio. So the final couple of marks are the ratio, and this is more like a probability question than anything else. So if you actually consider that if you look at the combinations of these, so somewhere or another it will tell you it has the 2 isotopes 35Cl, 37Cl in the ratio 3 to 1. So out of 4 atoms, 3 of them are 35 and 1 of them are 37. So 3/4 of them, 3 out of 4, if I had 4 atoms, 3 would be this and 1 would be 37. 3/4 would be 35Cl and 1/4 would be 37Cl. So what you actually do is, if I've got 2 35s, the chance of getting 1 35 is 3/4, the chance of getting a second 35 is another 3/4, and what you then do is, to work out the chance of getting one of the Cl's is 3/4, another 35Cl is another 3/4, you multiply the two together. 3/4 times 3/4, well, you could do it on a calculator, equals 9/16. You multiply the two fractions together. That's what you do. It's similar to, say for example, the chance of throwing heads are 50% multiplied by 50% is 25%. So it's a probability question. What's the chance of getting 2 37s then? Well, there's a 1/4 chance of getting 1 37, another 1/4 chance of getting a second 37. 1/4 times 1/4 is 1/16, and the remainder then is that. So you could work out the remainder, 10/16, the remainder is 6/16. So you could just do that by subtraction. Or you could say, if you wanted to work it actually out, then the chances are 3/4 of this one is a 3/4 chance of 35 Cl, a 1/4 chance of 37 Cl, that's 3/16, and one of them is at carbon number 1, one's at carbon number 2, or they could be the other way around, 3/16 and another 3/16 are 6/16. Although, as I say, if you work out that the first one has got a chance of 9/16 and the second one has got a chance of 1/16, that's 10/16, so the remaining part is 6/16 for this one here, MR222.